This is R.D. Sharma solution, class 12th, chapter 9, continuity MCQ multiple choice questions we are taking. If fx is equal to x plus 1 raised to the power cot x be continuous at x equals 0, then f0 is equal to. Now, you have to have a fair idea about log, then only you will be able to solve this. So limit extends to a fx, this I am telling you about the continuity. If it is equal to fa, in this case a is 0, so limit extends to 0 fx if it is equal to f0, then f0 is equal to what? So we have to actually find out the limit here. Limit extends to 0 for x plus 1 to the power cot x. So let us see how we do it. There are two methods actually. So I'll tell you both the methods. Fx is equal to x plus 1 raised to the power cot x. So let us take the log. So log fx is equal to cot x. When you take the log, the power comes in front. That is, it will be cot x, log x plus 1. So log x plus 1 raised to the power cot x will be cot x log x plus 1. So log fx is equal to cot x, then log, then x plus 1. Okay. Now this cot x can be written as 1 by 10x. And please remember this cot x is in front of log. So cot we can write it as 10x. So it will be log x plus 1 and divided by 10x. I'll just replace it by 10x. Now remember that when you take the when you take the limit of the the limit goes inside. That is, we have to apply the limit. That is what we are finding. So log extends to, limit extends to 0 for log x. It goes inside. So this will be log, limit extends to 0, fx. When you apply limit here, so there will be two, equality or trigonometric identities. That is, log 1 plus x by x is equal to 1 when the limit of x tends to 0. The second will be 10x by x, limit x tends to 0. This is also equal to 1. Alright. So when we apply the limit here, just assume that I have written limit. So log 1 plus x, now we have to divide it by x. So we have to multiply it by x also. And what about the tan x? So this is actually tan x because cot x we have brought down to the denominator. So tan x, you divide by x, multiply by x. Now what do you get? You get this cancelled. So log 1 plus x by x, as I just told you, it is limit extends to 0, it is going to be 1. Limit extends to 0, tan x by x, this will also be equal to 1. So eventually what do you got? So you get 1. And this is log, limit extends to 0, fx. So this is basically something to the power 1 is limit extends to fx. And since the base is e, the log base, we assume it to be, because we have taken the log, not base 10 but base e. Normal default value of log base is e. So e to the power 1, is equal to limit fx extends to 0. So basically log base yx is nothing but y to the power 1 is equal to x. So in this case the base is e. So e to the power 1 is equal to limit extends to 0 for fx. As I told you earlier that you need to have a fair idea about the logarithm, then only you will be able to understand this. So log base is e. Now e to the power 1 is limit fx extends to 0. So this is e. The answer here is limit extends to 0, fx is e. So f0 is e because basically f0 is what? The limit. As I told you, it is basically the limit. Now log and there is another method also. As I said, there is a simple method. Most of the time we generally avoid log. So we have a separate solution. The solution is very simple because ultimately you have to find out the limit extends to 0 for fx, which is x plus 1 to the power cot x. So what we will do here is, We'll just try to make the expression so that we get a simple limit and solution. So x plus 1, that is 1 plus x to the power, this is 1 plus x to the power 1 by x, and then you have x cot x here because x gets cancelled. We have introduced this x, that is why we have to write x cot x also. Okay, now this is 1 plus x to the power 1 by x, and then this is x by 10x, cot x is 1 by 10x. When you apply the limit, now please remember, if you know the limits, limit 1 plus x raised to the power x is e. So that is how the answer comes. Now if fx is equal to this, log 1 plus ax minus log 1 minus bx by x when x is not equal to 0, and it is equal to k when x is equal to 0. So limit x tends to a, fx is simply equal to fa. A is 0 in this case, in our case. So x tends to 0 it is. So this above function, which is not equal to 0, lower x equal to 0, which is k. So eventually we'll equate it to k only. We have to find out the limit. This is the only thing you need to keep in your mind. So limit x tends to 0. You have log 1 plus ax minus log 1 minus bx, and this is divided by x. So you can just separate it because the denominator is common to both of the above terms. Log 1 plus ax divided by x minus log 1 minus bx divided by x. Please remember, as I told you earlier also, log 1 plus x divided by x, limit x tends to 0 is equal to 1. So since we have ax, we have a in the denominator, numerator also we introduce. Since it is minus bx, so you can have a b minus b here, multiplied by minus b in the numerator. So let us apply the limit here. We are applying limit both the sides. So this is simply log 1 plus theta by theta, or log 1 plus ax by ax. This is going to be 1. Log 1 minus bx divided by minus bx. This is also equal to 1. So a minus of minus b, that is a plus b has remained, and that is equal to your f0, which is equal to k. Now this question, fx, the e raised to the power 1 by x minus 1, e raised to the power 1 by x plus 1. So continuity and discontinuity we have to check. So limit x tends to 0. Above function, let us call it as fx, and this is equal to fa, which is a is 0 in this case. So we just have to find out the limit of this e raised 1 by x minus 1 divided by e raised 1 by x plus 1, and then we'll check the continuity at 0 or not. So this is there are certain ways you can solve it. If you know about the limits, it's quite easy for you. Limit x tends to 0. We have e 1 by x minus 1 divided by e raised 1 by x plus 1. Now you just take this term, call it as some t or some p, whichever you want. I'm taking it as p's, for example. So it will be p minus 1 by p plus 1. So p minus 1 by p plus 1. When x is tending to 0, so 1 by x will be tending to infinity. So e to the power infinity it will be. So if e to the power infinite, anything to the power infinite is infinite only. So p is tending to infinite. So infinite minus 1 by infinite plus 1. So this will not be a proper way of solving it. So we'll try to resolve it. We'll try to get certain solution which is feasible. So limit x tends to 0. Now divide both numerator denominator by p, that is e raised 1 by x. We are dividing numerator denominator, that is e raised 1 by x, which I just called as p. So I'm doing it numerator denominator. So e raised x 1 by x by e raised 1 by x minus 1 by e raised 1 by x. Here also e raised 1 by x divided by e raised 1 by x plus 1 by e raised 1 by x. This is 1 minus 1. So 1 by e raised 1 by x. Now see here. I'm just replacing it by p. I'll just show what will happen. So I just told you that it is going to be infinity. When you apply limit, this p tends to infinity, what it will be? Infinity, 1 by infinity is 0. When you divide anything by infinity, it will be 0. If you divide any number by a huge number, a very huge number, it will be 0. So 1 minus 0 by 1 plus 0. So you get 1 by 1, that is 1. But this 1 is when the x is not equal to 0. And you get 0 when x is equal to 0. So 1 is not equal to 0. So it is not continuous. So I indicated you earlier that it may not be continuous. It may be made continuous. That is not the case. It is not continuous. That is the answer because we have devised it. Fx is x minus 4 divided by x mod x minus 4 plus a, and when x is less than 4. Similarly, x greater than 4, same term with the b, and a plus b when x is equal to 4. Then fx is continuous at x equals 4. So we have to find out the value of a and b. Okay. So this type of question we have done multiple times, but still we will try to complete it for the sake of completion. Okay. So limit x tends to a, fx equals f a. This is continuity. A is 4 here. So limit x tends to 4, f x you have to find out, and that has to be equal to f a, which is a plus b. So this is the number line. 4 we are going to check. If you go to the left, you have to put x as 4 minus h. If you go to the right, you have to put x as 4 plus h. Okay, 4 minus h and 4 plus h. So this is what we have to use. And the value of the x is equal to 4, so a plus b. F4 is already a plus b given in the question. Now, let us see what we can do here. We will try to do the LHL and RHL, left hand limit and right hand limit together. X we have to place, and 4 minus h, x equals 4 plus h in case of LHL and RHL as I indicated you. X minus 4, I am replacing it now. 4 minus h, 4 minus h minus 4 divided by mod of 4 minus h minus 4 and plus a. Here you have 4 plus h minus 4 divided by 4 plus h minus 4, and in this case 4 gets cancelled, 4 gets cancelled, minus h by mod of minus h. So this is in negative. So what do you get? You'll get this in. So this is plus a. So a, it will be negative because mod minus h is positive h. So a minus n you'll get. 4 gets cancelled, 4 gets cancelled, h by mod h. Here no problem with negative positive, so you'll get 1. You already have a b along with this, so plus b you can do, plus b. So b plus 1 you get here, and a minus 1 you get here. So this is equal to a plus b. So this is a minus b, 1 equal to b plus 1, and this is equal to a plus b. Now I hope you'll be able to solve this. A will come as 1 and b come as minus 1. Let us do it. A minus 1 equals b plus 1. So this is a equals b plus 2. So we'll replace this a equals b plus 2 in any of the equation. You can take any combination. There are 3. So a minus 1 equals a plus b you can take, or a minus a plus b equals b plus 1 you can take. It's up to you. And a, when you take b plus 1 equals a plus b, it's eventually you are going to get a equals 1 because bb gets cancelled. You can do it this way also, which I am doing. So there are multiple ways. So a is actually 1, and just put it here. So when a is 1, just put it in b plus 1 equals a minus 1, you will get b as minus 1. So this is how we get the answer. This we are going to take in the next discussion. Till then, thank you so much. Take care of yourself.